on the new concept note sheet. It should be on the new. And the title of these notes are, I say buoyancy, you say buoyancy?
I say it weird.
I always say buoyancy. And I'm wearing a lab coat because I don't want to get my clothes really dirty. I already did this morning, so I'm trying to prevent that further. So concept notes, buoyancy, and the journal title or journal number is 10. Everyone, I spell buoyancy wrong all the time.
That's right.
That's correct. I always say B-O.
I know, I put that.
All right, so somebody asked me this question, I don't know if it was in this class or in another class, about how it's possible that a boat floats. Don't worry about it, we'll get to it. How it's possible that a boat floats if it's made out of steel. Because the density of steel is greater than 1. And what we know is that in order for something to float, its density has to be less than 1. So how is this possible? Don't worry, we're going to get to it. So to do this and kind of get everybody thinking about it, we're going to do a simulation using clay. Hence why I have my lab coat on, because this clay makes it look like you have a really bad spray tan. And if you get it on your clothes, then you have a really bad spray tan on your clothes. So, what we first need to do is to calculate the density of clay. Now what I've done is I've made a cube of clay, and I've calculated the dimensions of the cube of clay. So what you need to do is you write 2 FICA boxes down in your notes so we can compute the density of the clay. Try not to get messy. And you've had a lot of practice with calculating densities by now, so you guys should be pretty good. So if we need to find the volume of something, what should go in the first box in our FICA box? What needs to go in this box in our FICA box?
Formula?
Yep, and what's our formula for volume?
Yep.
Volume equals length times width times height. And in the second box, we're going to put our information. Now, I already measured the dimensions of this, and 3 centimeters, 3 centimeters, and 3 centimeters. So I got volume equals length times width times height. The length, the width, and the height are each 3 centimeters because this is a perfect cube. So how would I find the volume? If I know my dimensions and I have formula. Yep. Now remember, 3 times 3 times 3 is not the same as 3 times 3. 3 times 3 gives you 9, but 3 times 3 times 3 will give you a different answer. So what should our volume with units be to the nearest 10? What is 3 times 3 times 3? Jacob. 27. What's our unit for volume? Centimeters what? Cube. Alright, so now I know that the volume of this clay cube is 27 centimeters cubed. Cool. Now I want to find the density. So what should this formula be in the first box?
Density equals mass over volume.
Yep, density equals mass over volume. And we know our volume is 27 cubic centimeters. And I actually mapped out this cube before you guys came in just for time purposes. So it was 54.6 grams. This cube has a volume of 27 cubic centimeters and a mass of 54.6 grams. All right, so if we plug this in, what should go on the top?
54.6.
54.6 grams, and what should go on the bottom?
27.0.
Cubic foot. Yep. So what should the density of the cube be if you plug it into your calculator? Take a second to try to, there's calculators in the middle of the table. Let me give some people some time to put it in. Now we've got 54.6 grams divided by 27 cubic centimeters. Jacob, what should the density be?
2.02 continuous.
Okay, so about 2.0, right? Units would be grams per centimeter cube. So this is the density of this clay cube. Now based on what you know about density, should this cube float, sink, or hover, and why? Kirsten.
It should sink because anything that has a density over 1.0 or exactly 1.0 is known to sink.
Okay, so, should we test your prediction?
Yeah.
Alright, ready? Alright, so did it sink?
Yes.
Okay, great. Now what I did is just for time purposes, let's hold my pinch pot. Skills are pretty good. Is I took one of these cubes that was 2 grams per centimeter cube, and I made it into this shape. So it's the same exact cube, I just made like a pinch pot out of it. So now, let's hope this works. My skills. Alright, ready? Whoop, goes the water. What happens to it? Alright, now I want you to talk with your group members for 2 minutes about how it's possible that something that's got a density greater than 1 could float. How is it possible?
Because of the air that's inside.
And it's all spread out, because the density spread out.
I'm wondering if you take it and flatten it out and try to put it in there, if it'll sink or float.
Take a couple minutes to talk to your group members. Do you have a question?
Do you think if you flatten it out, you think it'll sink or if it...
I don't know, maybe there's going to be something you're going to do tomorrow that might be able to. What? Bad spray tan, I know, right? So bad. Okay, take the next 30 seconds to finish up your thoughts with your group members about how it's possible that something that is more dense than water is now able to float. Alright, so raise your hand if you have any idea how it is possible that this clay is now floating.
It's kind of like a ballast tank. It has, it's in a circular shape, and it has air in it, so if you fill it with water, it probably sinks.
Okay, so you're saying that there's now air in this system, correct? Like in here. Does the mass of the clay change at all?
Nope.
No, I use the same amount of mass of the clay. Does the density of the clay itself change?
No.
Raise your hand if you think. Does the density of the clay itself change?
No.
No, because density, remember we said was an intrinsic property, it doesn't change. But you made an important point. You're adding air to the system now. When you add air, is air more or less dense than water? Raise your hand. Is air more or less dense than water? Less dense. So now I have air in here. And what else did I change in my density formula? Remember we said that density equals mass divided by volume, and I just said that the mass stayed the same. What was I able to change about the density of the overall, I didn't change the density of the clay, but the overall system, what was I able to change? I changed the volume, right? By adding air in and changing the volume. So what did I do to the overall density of the system?
You spread it out.
Did I spread out the density? What did I do to the density of this entire thing now? I have air in the middle, I made the volume bigger, and I kept the mass the same. So how is it able to float? What is the density of something that's able to float?
Less than 1.
Yep, so by changing the shape and increasing the volume, adding air to this, I was able to make the density less than 1 of the whole thing, not the clay, the entire system, and it was able to float. That's really similar to how steel ships are built, right? What does steel ship have in the inside of it? Air, right? And it's spread out over a larger volume. So that's how something like steel, which is a greater density than 1, is now able to float because you have air in a greater volume. Does that make sense to everybody? Anybody have any questions? Kind of weird to think about, right? Because we've been doing floating and sinking based on density. Yes?
Kind of like how submarine floats.
Yeah, submarines are made out of material that is more dense than water, but by adding air, right, you're able to change the density of the overall system. You're not changing the density of the steel, but the overall system, and that's what allows it to float or sink. So if I filled this with water, what would happen? It would sink, right? Because what's the air? It's kind of like ballast tank. So now you're replacing the air with the water, and it sinks down. That's like why if a ship sinks, what happens? The water goes into the ship and it sinks, because now you're replacing that less dense air with more dense water. Cool? So we've been talking about floating and sinking a lot, but there's actually a term that you can use for floating and sinking, and you're going to want to get this down, and it's called buoyancy, or buoyancy. I don't know how Mr. Faye says it. Buoyancy. You can say it cool.
I say it wrong, probably.
So buoyancy is the tendency of an object to float. We've been talking about floating and sinking a lot. Tendency of an object to float. And an even more scientific way of thinking about buoyancy is it's the upward force exerted by a fluid. So in this case, our fluid was water. So it's an upward force exerted by a fluid on an object. So in this case, it was our clay. That is partially submerged. Our clay was partially submerged. If you saw, did the clay sit like right on top of the water? No. Part of it was submerged. Do you have a question? No. So you want to get this. So we have buoyancy is the tendency of an object to float, and it is the upward force exerted by a fluid on an object that is partially submerged. So up here I have a picture of a boat. It's a object that is partially submerged. Does anybody know which direction the force of gravity acts on a boat? Does it push up or does it pull down? The force of gravity. Raise your hand, Keith.
Pull down.
So gravity is acting downward, right? Right, so gravity is pulling this ship down. So there must be something counteracting that pulling down that's allowing for the boat to still be remaining afloat. So which way would a force have to push or pull in order to make this stay afloat? So we've got gravity pulling down on something. Which direction must another force be acting to keep afloat?
Upward.
Upward. So we have an upward force. This is an upward force exerted by a fluid, in this case the water, on the boat. And this is called the buoyant force. Right, so on our little clay ship, there was a downward force of gravity pulling on it, pulling on like the weight of the ship. And then there's the water pushing upward. Because the force of the buoyant force, the force pushing upward was greater than the force of gravity pulling down, it was able to stay afloat. Does anyone have a question about that? Do you have a question? No? Cool. So you can relate the tendency of an object to float or sink to density, which you guys already have been doing. So if something has a high density, so we'll say a density greater than 1, does it tend to float or does it tend to sink? You gotta raise your hand. Raise your hand. If you know, if something has a high density that's greater than 1, does it tend to float or does it tend to sink?
Float,
High density. What do you think?
sink.
Why?
Because water is one, and if it weighs more, or if it's more dense than water, that's sink.
Okay, so now we have high density sinks. So a high density object sinks. This means that its tendency to float is low. So we call this a low buoyancy. So if something has a high density, it has a low buoyancy, meaning that it has a low tendency to float. Makes sense. Buoyancy. Sometimes they call this negative buoyancy, so I just put like a little negative sign. They'll refer to it as negatively buoyant. So if something has a low density, does it tend to float, sink, or hover? So a density, we're going to say less than 1. Does it tend to float, sink, or hover?
Float.
Float. So if we have something that has a low density, it's going to float. Apparently. So if something has a low density and it floats, does it have a high tendency to float or a low tendency to float? High. So this is called a high buoyancy.
I got to highlight this over here. I won't say who because I don't want to single a person out. But somebody over in this region right here, like just in this general area of class, is working on their flipping Webcam and bringing this information to us.
Oh, wow.
You do that too over there? Yeah, somebody over in that area apparently too. Over in
Yeah, this is a great way to get that double stamp by taking information from your notes and transferring them to the flipping Webcam. It's great. So if you have a low density, you're more likely to float, meaning you have a higher buoyancy. Sometimes we call this positive buoyancy. Does anybody have questions? What? Lab coat is like ugly lab coat. I should have dazzled it. Everybody get it all down? No? What's your question? Well, you're adding air to the system, which is compress the air in the balcony. You have a question?
I have a suggestion.
Yes.
To make sure that we should bedazzle it. We should tie to hide it and then put your name and little gems.
Maybe I will. Yeah, I will.
It'd be so fabulous.
It would be fabulous. Everybody get all down?
They'd hide that kid at Walmart.
Okay. I don't know why this slide keeps.
Do you have another slide? Or no?
Oh, yeah, I do.
Okay. Yes, I didn't want to hop in because I'm...
Okay.
This relates to what you're doing tomorrow, so here's where you want to
Yeah, you want to pay
definitely
attention.
pay attention because you have to build something tomorrow for us.
You can put it to the back if you run out of room. So in order to float in water, an object must displace. Another way we use the word displace, push aside. Push aside is how So in order to float in water, an object must displace or push aside an amount of water, displacing an amount of water, equal to or greater than its weight. So get this down, and then we'll discuss what that is.
11 minutes left. All we gotta do is go over this question so you can wrap up.
Like the last. If you want to jump in and talk about, I know.
Yeah, you know that I want to talk about.
Yeah, talk about it.
I'm actually really excited about this. Though this might seem a little dry right now, tomorrow you're going to have to use these concepts in a challenge that we're going to have you be kind of in a competition against each other to build something. So it should be good, yeah, for us, right?
In order to float in water, an object must displace, I like to think of it as like pushing aside an amount of water equal to or greater than its weight. So if you look at a picture, I like to use a cruise ship as an example, because we've been using boats and cruise ships all day, and you'll use them tomorrow. When you look at a cruise ship and you see it in water, do you see this part on top of the water? When you are watching a cruise ship floating in water, is this, can you see that, or is that under the water? It's usually under the water, right? And the reason why they have this big, is that called a hull? You know, it's called a hull, right? So this big hull, what it does is it pushes aside water. And by pushing aside the water, it is allowing the boat to float because it's pushing aside an amount of water that is greater than the weight of the boat. So the amount of water that this hull pushes aside is greater than the weight of the boat, and that's why it's able to float. And they don't make it equal to, because if you made it equal to and you added cargo and people on, then it would sink. You need to displace an amount of water greater than the weight of the boat to keep it afloat.
Yeah, actually something fun, if you ever go on a cruise with your family, or if you go when you're older, you'll show up at the cruise terminal and the boat's waiting there for everybody to get on. It even happens on like smaller cruises, like day cruises and stuff like that. Look at the boat while you're all waiting to go on, and you can see all that red paint at the bottom. It's called the water line. That's where they paint it like that, because it needs to have a funky kind of paint so it doesn't get all rusty and nasty. But if you look after all the people get on, the boat's like 10 feet further down into the water. It's actually kind of scary when you think about it. You watch all the people get on, and the boat goes like this.
It starts to push more water.
Load starts to push more and more water out as it starts to weigh more and more. So obviously you could overload the boat if you put too much on it. But everything up to that dark paint, see the dark paint all the way up to the top there? All the windows below that line don't open on purpose, because that means that anything below that white paint is capable of getting wet and get waves and all that kind of stuff, because that part's all watertight. You can't start opening windows and doors until you get above that blue area and into the white area. Okay, so it's kind of a cool thing.
Yeah, it's kind of cool that it relates to design, and you'll learn about that tomorrow as you create your boats, and you'll have to apply these ideas.
So 2 ways to do it.
Yeah, we're going to be doing a cool little challenge on that boat too. Did you have anything else you want to add, or can I take
Nope,
over and start
I
totaling?
used off, that answers the question.
All right, sounds good.